Asteroids Ryugu and Bennu are related. A star tried to eat a black hole, and it didn't go well. Using moons to save fuel, and China tests its new human lunar lander. In Space Bites Plus, how climate change will impact satellite orbits. All this and more in this week's Space Bites. We have samples of 3 asteroids, but the ones we have large amounts of came from 2 missions, Hayabusa 2 and OSIRIS-REx. Hayabusa 2 went to the asteroid Ryugu, while OSIRIS-REx went to Bennu. And they found that these asteroid targets were very similar. They were piles of rubble held together by their mutual gravity. They were the result of some kind of massive collision that happened earlier on in the age of the solar system. And now, after detailed detective work, scientists have realized the 2 asteroids are related. They actually came from the same mother asteroid. There's 2 methods that scientists use to figure out their origin. One is that they have the samples on hand, and so they can test the kinds of chemicals that are in the various asteroids. And the second part is that they were able to study both of the asteroids with the James Webb Space Telescope. In infrared, it was able to see larger characteristics of what they're made out of. And what they found is that the characteristics of both Ryugu and Bennu match the characteristics of a much larger asteroid called Polana. While Ryugu and Bennu are just a few hundred meters across, Polana is 55 kilometers across and yet shares the same chemical composition as the 2 smaller asteroids. So it's assumed that millions, billions of years ago, asteroids crashed together. One chunk of the wreckage became asteroid Polana, and the debris collected together to form Ryugu, Bennu, as well as probably countless other asteroids within the main asteroid belt. But it's sort of an amazing coincidence that the targets they chose happen to be related. Obviously, there's a lot of detective work that it took to get this answer, so read the article from Evan Goff that explains it. We have seen examples where a star gets too close to a black hole, and then the black hole starts to tear chunks of the star away. We see flashes of radiation, and eventually the star gets added to the accretion disk around the black hole, and eventually all that material will go into the black hole. But what if a star happens to engulf a black hole? Well, this is a situation that astronomers think they've seen. And keep in mind, while a black hole could have many times the mass of the sun, it's only a few kilometers across, so it's a very small compact object, while a star can be millions of kilometers across, and so it is the much larger volume, even though it is less dense. Astronomers detected a supernova in 2023 designated SN 2023 ZKD, and this had an unusual signature, and when astronomers went back and looked at archival data of this area, they could actually see signs that this object was already there, that there was something going on in this system. And then they measured the amount of radiation that was coming from the supernova, how it changed over time. And it was very unusual, very different from other objects. And so they think that there's sort of like 2 possibilities. One is that the black hole went into the star and that just made it unstable and caused the star to just explode as a supernova. The other possibility is that it actually consumed the star from within, and that still let out some energy that crashed into material that was in the surroundings, and that gave off the signature that astronomers are seeing. So it's still early days, but it's clearly a very weird encounter. And I get this question all the time from people, like, what would happen if a black hole fell into a star? Well, it's not good. And again, there's a lot of detective work that went into figuring this out. So check out the story from Evan Goff. In each of the giant planets in the solar system, there's the planet itself, like Jupiter, and then there's all of its moons, and all of them are very interesting. Ideally, you'd want to send an orbiter to each one of the moons at Jupiter, one at a time, but it requires a lot of energy to be able to do that. And there's only so much propellant that a spacecraft can carry on board to fill out its mission. But now a team of Chinese scientists have come up with a method that they think will allow you to do some of these maneuvers within a system around a planet without requiring a ton of fuel. And that's using 3-body interactions. And this is essentially a gravitational slingshot. And so we think about the traditional gravitational slingshot. You fly towards a planet, the planet pulls you up into its orbit, that gives you a speed boost, you can then go faster out into the cosmos. Or you can go in the opposite direction and you can use a planet to slow you down, which is actually what the Bepi-Colombo spacecraft is doing to be able to go into orbit around Mercury. But you can also just use the gravity of a planet to be able to change your orientation, to essentially kick around a planet or a moon and go into a new trajectory. And so what the scientists propose is that you can do three-body interactions between multiple moons and your spacecraft. If you aim your trajectory exactly right, you can use the gravitational slingshots around the moons to put yourself into different orbits that are useful for you while you're in the system, slowing you down. And in fact, you can do all this with a fraction of the fuel that you would normally require. And like, this idea is out now, and it would be really cool if, say, the upcoming JWST mission could somehow use it, but apparently it's too late. It's already sort of got its trajectory chosen, and it's not going to be able to take advantage of a three-body interaction to save some fuel while it's in the Jovian system. But we can see this on future missions. The Chinese are planning a mission to go to Uranus or maybe Neptune in the future, so maybe we'll see it then. And we've got a great story from Andy Thomaswick about exactly how this would work. There are a bunch of mysteries about the early universe, like why is there something and not nothing, and what happened to all the antimatter? But two of the big ones are, how did the supermassive black holes get so big so early on in the universe? And the other question is, how did we get out of the dark ages into this time when the rest of the universe was transparent? And it's believed that it has something to do with the first stars that formed, the ones that formed out of just the leftover hydrogen and helium from the Big Bang. They would have had almost no other heavier elements, any metals. They would have just had this raw hydrogen and helium. And this first generation of stars, they're known as population 3 stars. And I know that's confusing, but it's assumed that because they were made of this pure hydrogen and helium, that they were able to form a lot larger than stars are able to do today. But other simulations are showing that that's probably not the case, that they were still limited. So there had to be some other mechanism that allowed them to get larger or release more energy when they detonated. And so a new paper is proposing that maybe dark matter has some kind of role to play. Dark matter doesn't seem to interact with regular matter or itself, but it's assumed that if it is some kind of particle, that if you get it into a close enough region, it will annihilate with itself. And if it does, it's going to release a lot of energy. And so in this paper, astronomers propose that you get stars with clumps of dark matter in their core, which is doing the self-annihilation process that is releasing more energy. And you're getting these stars growing rapidly and detonating very quickly and releasing a lot of energy. And this energy is then ionizing the hydrogen that's left over in the universe. And so instead of it being a very long process to go from the dark ages to the age of reionization, that maybe if this process happened, that it actually was very quick and you had almost more like fireworks going across the universe, clearing out all of the murk so that everything was going to be visible. It's a very cool idea, and this is just like a short version of it. So you're going to want to check out the longer version written by Mark Thompson. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner this week was the biggest black hole ever found. So thank you everybody who voted last week. We'll put the new vote into the post tab here on our YouTube channel, and you can go there, you can vote. And of course, the best chance to see this poll every week is subscribe to the channel, click on the notifications bell, and then just train the algorithm. On August 6th, China tested its new lunar lander for the first time. This is the Lanyue, and it looks very similar to the Apollo lunar module, the LEM, that we're familiar with. It has a descent module and then an ascent module that sits on top of that. The Chinese astronauts are going to be in orbit around the moon in their Mengzhou capsule, which was delivered separately. They'll get into the Lanyue. It'll go down to the surface of the moon. They'll get out, they'll do their mission, they'll get back in, they'll ride the ascent module back up into orbit. But it's much more massive than the original LEM was. While the LEM had just over 10,000 kilograms deployed to the surface of the moon, Lanyue is expected to do 26,000 kilograms to the surface of the moon. And so on August 6th, they did this test. It ran for about 30 seconds and they tested simulating the descent, the guidance, the control, and the engine shutdown, which are a lot of the big key components of this. And of course, they've got a lot of practice with landing stuff on the surface of the moon, as well as flying ascent modules off the surface of the moon with all of the sample return missions. And so, the humans are just going to be bigger versions of sample return. And so this is tested here on Earth, but the plan is to then have this fly on the heavy lift Long March 10 vehicle, which is what they're building. They're expected to test that in 2027. And so now all the pieces are coming together for the Chinese mission to go to the moon, which is expected to fly by the early 2030s. Obviously, there's a lot to go into on this, so check out the story by David Dickinson. Not only can Webb explore the distant universe, study the atmospheres of exoplanets, it can study objects right here in the solar system. And astronomers were using Webb to examine the area around planet Uranus, and they discovered a 29th moon. So it's designated S2025U1. Who knows if it'll ever get a more interesting name. And the new moon orbits about 56,000 kilometers from the center and takes about 9.6 hours to orbit around it. So it's very close in to the planet. Has an almost perfectly circular orbit, which tells you that it probably formed in place and wasn't captured by some other interaction or with a Kuiper Belt object. And it's about 10 kilometers across. So another new moon for Uranus. Thanks, Webb. And we've got a story about that by Evan Goff. All right, this is very cool. So NASA's Psyche mission is currently on its way to the asteroid Psyche. I know, every time I bring this up, it's totally not confusing. But Psyche launched in 2023, and it's expected to arrive at Psyche in 2029. And so we're about halfway through the cruise phase of its mission. And one of the things that NASA likes to do is have these spacecraft turn back and take a picture of Earth. We saw that with Voyager with the famous pale blue dot image. We saw that with Cassini with its own version of the pale blue dot. And other missions have done this as well. Beyond just giving you this incredible sense of perspective that everyone you've ever known and lived and loved is on that tiny little blue dot hanging in a ray of sunlight, it also is useful to test out the capabilities of the spacecraft. We know the color of planet Earth. We know the color of Jupiter. We know what Mars looks like. And Psyche has been able to take images of each of these objects, and then the mission controllers can use this to calibrate the science instruments on board the spacecraft so that when it does start to approach its final target, asteroid Psyche, it will be able to take the best possible data. And there's a couple more targets that it can probably still take pictures of. You've got Vesta, you've got Saturn, and again, it'll arrive at Psyche in 2029. And check out this story by Evan Goff. I hope you enjoyed all of the stories so far. And of course, this is just a fraction of all the cool space news that I'm keeping my eye on and what we're reporting on at Universe Today. For example, you could detect exoplanet magnetic field from the moon. And this is a story by Evan Goff. What is the current locations of all of the interstellar objects that we've seen so far? And this is a story by Matt Williams. And researchers simulate what the shadow of a black hole would look like. The story by Evan Goff. Now, I am writing my weekly email newsletter that will contain all of the stories that we're working on, which is usually between sort of 30 and 40 different stories. And the newsletter just contains short descriptions of every single story that we're covering, written by me. And so that way you can just quickly browse through all of the important space news of the entire week and be completely caught up to date. You don't need anything else, just my newsletter. And it's completely free. We don't put any ads in it. And if you want to subscribe, go to universetoday.com/newsletter to sign up. Now, do you want more space news? We've got the exact same episode, but with one additional story. And because it's on Patreon, you can watch it completely for free with no ads. And this week's bonus story is about how climate change is going to impact satellite orbits. And I'll put a link in the show notes. I'm going to rant a little bit about Earth observation and NASA, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Braley Roofing, Brian Bowder, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nelson, David Gilton, and David Matz, Evan Pro, Hudson Moore, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Modzo, Nick Borges, Nick Solari, Paul Robach, Brent Kaidu, Richard Williams, Son Sargent, Stephen Fowler Manley, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. As you're probably aware, NASA still doesn't have an official permanent administrator. So that's a thing. Where are we now? 200 days in, and NASA still doesn't have an administrator, although a lot of actions are being taken on behalf of NASA. We're seeing a lot of early retirements. We're seeing a lot of potential budgetary cutbacks. We're still waiting for the final hammer to fall on this, but it could be fairly devastating. And one of the big incentives that we can now see is that the acting administrator, Sean Duffy, who is also busy with his other job as the Secretary of Transportation, and this is just one of, I think, like 10 different groups that he has to work with. So again, NASA is kind of leaderless right now, or at least can't be as focused as we would all hope. And yet, obviously, we've got this race between NASA and the Chinese and other people to try and return to the moon. And just like, what is the future of space exploration going to be about? And so right now, the current budget for NASA, which was requested by the White House administration, calls for about a 25% cut of NASA's budget, calls for the cancellation of about 41 missions, calls for no funding for various flagship missions like LISA, Nancy Grace Roman, other missions like that, and really slashes Earth science funding by up to 47%, with a heavy emphasis on taking away budget from Earth observation. And so, again, we don't know how this is going to all play out, but now we're about a month away from this deadline, and we could see things start to unfold. So, and keep in mind that understanding space, and there's weather and space weather, where, we know that things that are happening on the sun, solar storms, influences the Earth. How you have coronal mass ejections, you can have solar storms. These can have an influence on communications, on satellites. A lot of the most devastating natural disasters are tracked from space, hurricanes, things like that. Tracking the carbon dioxide that's being emitted, the methane, being able to detect leaks of methane, being able to watch the growth of wildfires from space, be able to coordinate. All of these are the science that NASA does and makes humanity better as a result. And this uncertainty is already causing problems. We've seen that NASA has already let go of about 20% of its staff. And yet this is all like people taking early retirements and cuts here and there. That's going to have an impact on the ability of NASA. This is the lowest level of NASA employees since the 1960s. We are watching NASA be disassembled in real time. And I know this could have been one of the stories that we covered earlier on in this episode, but it's so uncertain that I have to express myself. I had to get this out there. And so it feels more like it has to be a rant at the end, or like an editorial, and that's what it was. But as always, I will keep you posted, and we'll see you next week.